Hello and welcome to R&D Mathematics. Today we are going to talk about properties of logarithm. Properties of log. Now, first one, log base b1 is always 0. Now, why is that? Let's say let u be log base b1, right? And then if we convert this into exponential form, b to the u equals 1. But we know b to the 0 equals 1 and hence u equal 0. So that's the reason. In other words, any base log, any base 1 is 0. And this is the reason why in our logarithmic function here 1 comma 0. Because that value log 1 is always 0. Remember that. And the next property, log base bb, that is 1 because b raised to which power is b? That is just 1, right? You can verify this exactly like here. Now let me, let, in this case, let u be, let u be log bb. So we have b to the u equals b, but we know b to the 1 equals b, so u equals 1, right? And the third property, log base b to the x equals what? Can you guys think about it? B to the x equals x. Remember, logarithm and exponential function are inverse of each other. That's why this is happening. In other words, if you do the same trick, see, if let me take it over here. In this case, it's straightforward, right? Because log base b to the x, and if you say let be u, that guy, and then this is how the proof goes. B to the u, that b is here the base argument, is going to be, sorry, exponent is going to be this argument here, b to the x. So u equals x. See, that's the proof. Similarly, we have the other way around, b raised to log base bx also x. Now these two things, I mean, you can check it exactly like the third one, so I'll leave that for you. Now what you need to remember, this happens, log and exponential are inverse of each other. That is the reason why that happened. Now next property number 5, product rule, log base b mn. Product of a log is going to be sum of those logs. Now these are the few rules, let me write down those rules and explain. Log base b quotient rule, that is going to be log base bm minus log base bn. And finally we have the power rule, log base bm raised to p, then you can simply take that p forward. So log base bm. Now let me explain these things. So let me explain from 5 onwards. Fifth one. Now the reason why fifth one is true, now let's say, so here the fifth proof. So let's say u equals log base bm and v equals log base bn. Now From here we have b to the u equals m and b to the v equals n, right? Now if I take these two guys and multiply, left hand side I have b to the u times b to the v and mn. So I simply multiplied these two equations as it appears. So I have b to the u plus v equals mn, right? Now if I convert this back into log, what I'm getting is log base b mn equals u plus v, right? But u is log base bm plus log base bn. The reason why this happened, as you can see this number 5, this property is the log version of this property. Log version of exponential property, right? Similarly, this one in the proof you will get log version of exponential, power properties, that one. So I'll leave that for you to deal with. Now let me go ahead and do the proof of number 7. And 7th one proof. In this one, let's say let's say u equals log base bm. So I have b to the u equals m, right? Now I'm going to take pth power of both sides. So I raise to p both sides. I can do that. So b to the up is going to be m to the p, right? Now if I convert this into log, so log base p m to the p equals up, right? Because here now I'm taking this guy as my exponent and this guy as argument and this as my base. Think about it for a second. And now we know u is log base. So let me, I can rearrange pu. So p times log base bm. See, it's been proved. Now let me give you an example of this. You don't need to remember the proof, but proof is easy. Let's say, log base 10,000. You know this is 3, right? Because 10 raised to which power is 1000? 3, right? But this 1000 I can write log 10 to the 3, right? Now if I use this property over here, 3 comes forward, log base 10, 10, but you know this guy is 1, right? So 3 times 1 is 3. See, that's straightforward. And let me give you 1 or 2 examples of number 5 and 6. Using simple numbers, then it will make sense. So let's say log base 10. Again, let me take 1000. You already know this is 3. Now I can write 1000 as 10 times 100. Now according to my 5th one, now m is 10, n is 100. According to that rule, I must have log 10, 10 plus log 10, 100. Log 10, 10, that's 1. Log 10, 100, that's 2. 1 plus 2, that's again 3. See? Okay, I think now you can understand these properties well. Now using these properties, we are going to, in the next video, we are going to simplify expression using all of these properties. Okay, thank you.